In this lesson, we'll be looking at surface area and volume of irregular shape. So irregular shapes, or our main goal is to determine the surface area and volume of composite shapes. Composite shape means you are a shape that's composed of two or more different kinds of 3D shapes. And the previous lesson, we looked at cones, we looked at cylinders, we looked at spheres, we looked at pyramids, and we look at cubes. So those are the various ones. And if you look back to our formula sheet here, we look at these as separately. We find the surface area of a rectangular solid, of a sphere, a cone, cylinder, pyramid, or a triangular prism. Composite means we're combining two or more of these different kind of shapes or 3D objects. You may combine a cylinder with a cone. You could have a rectangular solid and a square pyramid, or a triangular prism. So that's what we mean by composite. They're composed of two or more different kinds of 3D objects. The first one we'll be looking at, they ask us to calculate the volume of this composite shape. Now, this is called a composite because it's a grain elevator where to store grain in. And the lower part here is a cylinder. So it's flat. So here you have a cylinder, and top part you have a cone. If you look, so we'll be using, if you want to find the volume, you're looking at the volume for the cylinder and the cone. So that's mean by composite, meaning composed of two or more. So it asks us here, the following shape is a grain silo. It stores grain in a dry place until needed or sold by a farmer. It is made up of a cylinder. So this is our cylinder here. So it's made up of a cylinder and a cone. So this is your cone at the top here. Now the height of the cone, we put h here, the height of the cylinder is h, and the diameter is 12. So the radius here will be 10 meters. The tire, so we have 10 meters also here as our radius. We'll need the radius for the cone. To find the volume, we have to find the volume, the total volume now of this composite shape. So the total volume is equal to the volume of the cone plus the volume of the cylinder. So you have to find the volume for each of these and then add the two to give you the total volume. So let's highlight that. So let's find the volume of the cone first. So volume. Now we have to go to our formula sheet, and we know the volume of a cone is 1/3 pi r squared times height. So we'll record that. 1/3 pi times the radius squared times the height. From our diagram, we found that the height, so we'll put this in a box here. The height The height is 35 meters. Our radius is 10 meters. So the cone, so we need a radius and a height. This is the height of the cone. Now, the height of the cone is not 35, the height of a cylinder. So let's clarify that here. So the height, let's write this a little bit orderly here. So we have our radius for both of these, for cone, is 10 meters. Now the height for the cone, this height here, which gives us 8. Okay. And the height for the cylinder is equal to 35 meters. Just make sure we differentiate them. So now this would be equal to 1/3 pi multiplied by the radius, which is 10 squared, multiplied by the height, which is 8. Just going to remove this for now. So the volume of the cone now could be equal to 1/3 times 10 squared. Let's work that out. So you can go backwards. We have 8 times 10 to the power 2 squared. It's going to give us 800 here. Multiplied by pi, 1/3. So multiply that now by pi. Give us 2513.27. Now I'm going to divide it by 3. Which gives us an answer of 837.76 cubic meters. So the cone is 8.37.76 cubic meters. Now we need to find the cylinder. So volume of a cylinder, and we go to our formula sheet here, and we say the volume is pi r squared times height. So pi times squared times the height, which is pi. We know the radius is 10, so we put 10 squared multiplied by the height of the cylinder is 35. Don't confuse it with the cone. And this worked out to be, let's see here. Okay, let's get this up here a little bit here. 35 times, now 10 to the power 2. 3,500 times pi gives me an answer of 10,995.57. So volume of cylinder. Let's go back to my sequence. So that's 10,995.57. I'll just rewrite it below here. So we write, I'll just so total volume is equal to volume of cone volume of cylinder. Volume of cone, we said is 8 more. Result here. There's the volume of a cone. Volume of a cylinder below here. So here we have volume of a cone, volume of a cylinder. So it's 837.76 cubic meter plus 1099, 1095. Add the 2, we got 11,833.33. So we can conclude the total volume of the silo is equal to 11,833.33 cubic meter. Okay, let's go on to example 2. Here we now in this example, we're asked to find the amount of cement to manufacture these sewer pipes. So a company manufactures cement sewer pipes. The pipes have a thickness of 4 inches, and the hollow portion has a diameter of 36 inches. The pipes are sold in 20-foot length. Calculate the volume of cement required to manufacture 1 pipe. So let's make an illustration of this question. This is not given here. The first question, the diagram is given with its dimension. Here is not. So if I were to do a sketch of this diagram, we have a cylindrical pipe. So it's cylindrical. So here we have our pipe here. Now looking from this view, it said that the thickness here is 4. So let's look it from here now, right? So we have this thickness here. Of the pipe. So the thickness this here is 4 inches. Now it tells us that the hollow part has a diameter of 36 inches. Now this is the hollow part here. This is your hollow part from here to here. It's 36 inches. So we have 2 circles here. We have one circle with diameter is 36 inches. Now the other one, which is the outer part of the outer edge here, now from here here, the longest, if you look at the outer edge now, it's 4 inches to the right and 4 inches. So it gives the total would be equal to 44. So if you were to look at from one end here to the other end, the longest part here, this would be 44. Now this pipe now, it goes down. If I were to extend this pipe this way here, this pipe go like this here all the way down here. So we have the outer part of it here is 44, and the inner part is 36. The length of the pipe is 20 feet. So we have to be careful how we work this out now. We have to convert now all of them into the same unit measurement. So the simplest way is to convert inches to feet. Now there are 12 inches equal to 1 foot. So this first step is to convert all of your unit into one unit. In this case, you'll convert to 12 inches, all of your inches now, into feet. So let's go ahead and do that here. We know that 36 inches is equal to 3 feet. Because we know 12 inches is equal to 1 foot. So if now we have 44 inches, so we want to convert it to feet. So to convert feet, or inches to feet, to convert inches to feet, we take our inches and divide it by 12, because there are 12 inches in a foot. So now we have our outer dimensions 44. So 44 inches is equal to 44 divided by 12, which works out to be 3. Let's see how that be. 44 divided by 12, 3.67 feet. So that's the outer part here, dimension of it. The inner part, which is 36 inches, 36 divided by 12, that's 3 feet. So now we have all of our units now in feet. We now have to find the amount of material now to make this pipe. If I were to, so the volume of cement, it means you find a volume for the outer pipe here, right? And then you find a volume for the inner pipe, and you subtract them. So we are actually finding the outer pipe here, find the volume, and you punch in a hole in it. The hole is represented by the inner pipe. So the volume of cement is equal to volume of outer pipe minus the volume of inner pipe. Because this is basically the hollow part here. It's like you have a solid pipe, the beginning of it. Let's imagine there's no hollow here, there's a solid pipe. And that will represent the cement of the outer pipe. Well, then you're going to remove the inner pipe, which is the volume of the inner pipe. That's why I'm subtracting it. So let's go and find the volume of the outer pipe. So the volume of the, which is a cylinder here. So the volume of outer pipe Now, go back to our formula sheet. Remember, we said that a cylinder is pi r squared times height. So I'll use that. Which is pi, and we know the radius. Now, the radius for the outer pipe will be half, right, of the, so here we have a length of 3.67 because initially we said it's 36. So the radius is going to be half of this. So what would that be? So we have the radius is equal to 3.67 divided by 2, which will give me 1.83. So the radius here is 1.83 squared. Now we multiply by the height. Now the height of the pipe is 20. That tells us the length, which is referred to the height, 20. Now we do that. Now we have our square. So I'm going to square this guy since I already have it in my calculator. Multiply by 20 times pi. 211.18. So 211.18 cubic feet. Now that's the outer pipe. We now have to go and find the volume of the inner pipe. So you still pi r squared times the height. Now the radius for the inner pipe, say 3 feet, so half of 3 feet will be 1.5. So we have pi, so radius is equal to 3 divided by 2, 1.5 feet. So we have 3 divided by 2 gives us 1.5. So 1.5 squared. The length is still the same as 20 feet. So the height is 20 feet. Oops, that here. Now, do a calculation here. We have 1.5 squared times 20 times pi. Gives me 141.37 cubic feet. So these are 2 dimensions. Outer pipe, inner pipe. So the volume now will be, we subtract these 2. So the volume of cement volume of cement is equal to volume of outer pipe minus volume of inner pipe. And that worked out to be the one the outer pipe is 211.18 cubic feet minus 141.37 cubic feet. And that worked out to be 211. 69.8. So 69.8 cubic feet of cement. So they will end up with, you have to have 69.8 cubic feet of cement to make one of these pipes. That's your final answer. So step one, when doing a question of this nature, is to, when it's giving words, you will have to do an illustration of the question to help you to visualize what it is. Then, once you have a diagram, you indicate your dimensions. In cases where they give you different units, you have to convert all of the units into one unit you could use. In this case, I use feet, but you could have used inches, but you end up with a use set of values. Okay, we'll look at a couple more questions. Here they ask you to find the surface area of the missing pieces. Find the surface area of this container that has a bottom but no lid. So there's nothing, no lid here. Now, if you, this is a cylinder, you know right away. So it has a bottom but no lid. So there's no top here. If you look at a cylinder, here we have top and bottom, top or bottom. So here we have our top and bottom. This is our side. So we have no lid. So we have to remove one of these circles because these are both top and bottom. So remove the twos, and then we have our volume. So this is cylinder. Volume is equal to pi. Oh, we're looking for, oh, sorry, surface area. We're looking at surface, not volume. I'll change surface area. So surface area, which is 2. So we look at the side first, plus the bottom. So 2 pi r times the height plus the bottom going to give me pi r squared, because it's only a circle here at the bottom. So we find the area of the circle and the sides of it. Now we need to find our dimensions. So we need radius and height. So this is our height here. So h is equal to 4 the radius now is the half of a diameter, which is 1.5 inches. That's all we'll need for these. So now we substitute our value, 2 times pi. The radius is 1.5 times the height, which is 4. Now they're all the same units, so we can multiply these numbers. If there were different units, we have to convert them into 1. The previous question, it was in inches and feet. We had to convert the inches into feet. This can be pi, and the radius here is 1.5. So here we have the sides. So 2 pi r times 1.5 times 4, well, it gives me 37.7 inches squared. And this is 1.5 squared times pi, or up to 7.1 square inches. Combine the two, we end up the surface area will be equal to 44.8 square inches. Okay, let's go to the final example in today's lesson. Here we're looking at a combination of rectangles, or maybe squared, and triangles. Here, for the calculated surface area of the following box, use it as a mold to make triangle chocolate treats. It has a bottom but no top. So there's no top. This part is no top here. The peak of the end triangle is 3.12 centimeters from the base. So this is a triangle. So giving us here, this indicates a triangle. Because we need the height of a triangle to find its surface area, or its area. The sides are rectangles. They're 4.5 centimeters by 4 centimeters. So we have all the units are the same. So there's no need for conversion here. The surface area now, you have to find the surface area of the side. They have 3 sides. Now notice all of the sides, they have the same dimension. So this one of the sides 4 times 4.5, this is 4. This will be also 4.5. This would be 4, this would be 4. Okay. There's a triangle at the bottom here. It's exactly as the one at the top, but so we're only finding the area for one triangle because there's no top. So the surface area then will be the surface area of the 3 sides plus the surface area of the bottom. So we can write that down here. Surface area is equal to area of 3 sides plus the area of the bottom. Now, the area of the 3 sides, this part now. So area of 3 sides, and they're all rectangles, right? So they're rectangles, so which is length times the width, right, which is length times width. And we find for 3, so we have 1, 2, 3. So we have 3 side 1, 2, and the other side now is 5, so it's longer. So we have this other side here is 5 times 4. So we have 2 sides are the same, plus the other side length times width. So you have 2 sides the same, and the back side is not the same. So we have 2 times 4.5 times 4 plus the length and the width. The other one is going to be going to give us what? 4.5 multiply this is here times 5. So this gives us what? 36. 4 times. Let's see what that gives us here. 4.5 times 4 give us 18. 18 times 2 is 36. And 5 times 4.5 give us 22.5. Put them together, so we have the sides equal to 58.5 centimeters squared. So these are the 3 sides. Now we need to find for the bottom, which is this triangle here, which is 5, and the height here is 3.12. So the bottom, so we have area bottom, which is a triangle. So we have base times height divided by 2. So here's your base, and your height is give us base is 5 multiplied by the height, which is 3.12. Okay, so this is your bottom here. So we have 5 and the height here, which worked out to be 5 times 3.12. .6 cubic centimeter. So now here we have our 2 dimensions. 58, those are the sides, and that's the bottom. Oh, did we divide by 2? We did not. Did we divide by 2? I don't think we did. No, we did not divide by 2, so we need to divide by 2. 7.8. So this is wrong, so divide this by 2. Because we need to divide by 2, base times height divided by 2, because it's 1. That will give us 7.8. So the bottom is really 7.8 centimeters square. So now this is our final answer. Sorry about that mistake. I just overlooked and divide. So these are my 2 areas. So I combined the 2. So the area, now if I put back in my phone the 3 sides, going to give me 58 0.5. Plus the bottom is 7.8. Which worked out to be 58.5, 66.3. Very so good. I'll just right to the bottom here. So the final answer, total surface area is equal to 58.5 centimeters square plus 7.8 centimeters square, which is 66.3 centimeters square. So we have area of 3 sides. Here at the bottom, it's a triangle. I'm going to put an indicator, these are rectangles.